Hello, and welcome to this video relating function composition and average rate of change. Recall that the average rate of change of a function f on the interval a, b is given by the quantity f of b minus f of a divided by the quantity b minus a. In the figure below, we see the familiar representation of the average rate of change of f on the interval a to b as the slope of the line joining the points a f of a and b f of b on the graph of f. In the study of calculus, we progress from the average rate of change on an interval to the instantaneous rate of change of a function at a single value. The core idea that allows us to move from an average rate to an instantaneous rate is letting the interval from a to b shrink in size. To think about the interval a to b shrinking while a stays fixed, we often change our perspective and think of b as a plus h, where h measures the horizontal distance from b to a. This allows us to eventually think about h getting closer and closer to 0. In this context, we label the other point on the graph a plus h, comma, f of a plus h. We are familiar with the formula for the average rate of change of f on the interval ab being equal to f of b minus f of a all over b minus a. With our new change in perspective, namely thinking of b as a plus h, we can now consider the equivalent expression, the average rate of change on the interval a to a plus h equals f of a plus h minus f of a all over a plus h minus a. Simplifying the denominator gives us the average rate of change on the interval from a to a plus h equals f of a plus h minus f of a all over h. And this represents the average rate of change of f on the interval from a to a plus h. In this most recent expression for the average rate of change on the interval from a to a plus h, we see the important role that the composition function f of a plus h plays. In particular, to understand the expression for the average rate of change from a to a plus h, we need to evaluate f at the quantity a plus h. Let's look at an example to see how this works. Let f of x equal 3x squared minus 1. Determine the simplest possible expression you can find for the average rate of change on the interval 2 to 2 plus h. The average rate of change of f on the interval 2 to 2 plus h. Finding the average rate of change of f on the interval from 2 to 2 plus h means that graphically we are going to find an equation that tells us the slope of the line joining the point 2f of 2 and some other point that is a horizontal distance away from x, and that horizontal distance is h. By definition, we know that the average rate of change from 2 to 2 plus h equals f of 2 plus h minus f of 2 all over h. Using the formula for f, we can see that f of 2 plus h equals 3 times 2 plus h squared minus 1. Squaring the 2 plus h gives us 2 plus h times 2 plus h times 3 minus 1. And then if we multiply 2 plus h times 2 plus h, we get 4 plus 4h plus h squared. So we have 3 times that quantity minus 1. Distributing the 3 gives us 12 plus 12h plus 3h squared minus 1. And when we simplify that, we find that f of 2 plus h equals 11 plus 12h plus 3h squared. And using the formula for f again, we see that f of 2 equals 3 times 2 squared minus 1, which simplifies to 11. Now we can substitute these known quantities into our formula for the average rate of change from 2 to 2 plus h. So we're going to replace f of 2 plus h with the quantity that we just found, 11 plus 12h plus 3h squared, and we will replace f of 2 with the value of 11 that we just found, and we will divide all of that by h. We notice that the 11s will cancel out, and removing a factor of h from the numerator and noticing that h is not equal to 0 means that we can simplify, and we find out that the average rate of change from 2 to 2 plus h equals 12 plus 3h. And this equation tells us a formula that will give us the average rate of change of f on an interval of any length starting at t equals